Hello everyone. In this video, we are going to discuss about the blocks in the modern periodic table from the chapter 3 classification of elements and periodicity in properties class 11 chemistry. See, we will be discussing about the F block elements or inner transition elements in this video. We have already discussed about the S, P and D block elements in our previous videos which are available in the playlist. So you see, the two rows of elements at the bottom of the periodic table are called lanthanoids and actinoids. See, lanthanoids, it starts from cerium to lutetium, and when it comes to actinoids, from thorium to lawrencium. Okay, so these two rows of elements which are actually called as lanthanoids and actinoids, they are actually the F block elements, or which are also called as inner transition elements. So you see, when we consider the F block elements, their outer electronic configuration will be like this: n-2 F raised to 1 to 14, n-1 D raised to 0 to 1. That means D can have value 0 or 1. Then ns2. This is the general outer electronic configuration for F block elements. That is, for example, if you consider one of the F block elements, which is cerium, its atomic number is 58. So when you write its electronic configuration, you will get it like this. By using the Offer principle, Pauli exclusion principle, etc., we can write their electronic configuration like this. Okay, so here when you look at the outer electronic configuration, that is 6s2 4f2. So this is like 6s2, that is ns2. Okay, so ns2, that is 6s2. Then n-1 D raised to 0 to 1. n-1 means 6 minus 1. 6 minus 1 is 5. D raised to, see 5D is not here. So it is like 5D raised to 0. 5D0. Okay, because D can have value 0 as well as 1 in this configuration. Then n-2 F raised to 1 to 14. n-2 means 6 minus 2. 6 minus 2 is 4. So 4 F raised to, here we have 2. So you see, the outer electronic configuration of cerium, it is as per this general outer electronic configuration. Similarly, when you consider any other F block element, its outer electronic configuration will be like this. And here you see, for the F block elements, the F orbital, it is not completely filled by electrons, because the maximum number of electrons possible for an F orbital is 14. Here we have only 2 electrons in the F orbital. Similarly, when you consider any other F orbital, F block element, its F orbital will not be completely filled by electrons. So, in the F block element, the last electron is added to each element is filled in the F orbital. That is, in the F block elements, the last electron is added to each element is filled in the F orbital, because F orbital is not completely filled. S orbital is completely filled because maximum number of electrons possible in S orbital is 2. It is completely filled. But when you consider F orbital, it is not completely filled. So the last electron which is added to each element will be filled in the F orbital. So you see, these two series of elements, that is lanthanoids and actinoids, they are actually called as F block elements, and it is also called as inner transition elements. See, when we have discussed about D block elements, we have seen that D block elements which are called as transition elements, and F block elements are called as inner transition elements. See, F block elements are called as inner transition elements, that is lanthanoids and actinoids are called as inner transition elements. See, inner refers to the fact that electrons are filling the inner F orbitals, that is 4f orbitals, which are deeper in energy level than the outer S and P orbitals. And transition refers to the fact that these F block elements exhibit a gradual transition in properties between S block elements and D block elements. Okay, and you see, F block elements are metals. See, a large number of oxidation states are possible for actinoids. Actinoids have partially filled f orbitals which can lead to multiple oxidation states. For example, when you consider uranium, its atomic number is 92. The oxidation states possible for uranium are plus 3, plus 4, plus 5, plus 6. So the same element can have different oxidation states. Similarly, when you consider plutonium, its oxidation states are plus 3, plus 4, plus 5, plus 6, plus 7. So actinoids have partially filled f orbitals which can lead to multiple oxidation states. And you see, actinoid elements are radioactive. That is, they can emit radiation and undergo radioactive decay. And you see, the elements after uranium, they are actually called as trans-uranium elements. That is, when you consider this periodic table, here we have the F block elements, and you see here we have the uranium, which is an actinoid, which is a radioactive element. And the elements after uranium, that is, these elements are called as trans-uranium elements. That is neptunium, plutonium, americium, please excuse me for the pronunciation, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, and lawrencium. So the elements after uranium, they are actually called as trans-uranium elements. So in this video, we have discussed about the F block elements. I hope it is clear to you. Thank you.